Okay, we're going to talk about finding the greatest common factor. And I know that you guys have done this before with just numbers. So just a quick review. Let's say I have the number 24 and the number 16. First of all, the factors of 24 are going to be the whole numbers that can be divided into 24 evenly. So those would be 1, 2, 3, 4, 6, 8, 12, and 24. All of these numbers are factors of 24. They can be divided evenly into 24. If we list the factors of 16, we get 1, 2, 4, 8, and 16. Those are all of the numbers that can go evenly into 16. The greatest common factor, which is shortened to GCF sometimes. So we're looking for the largest one of these factors that are common to both of them. What is the largest number that can go evenly both into 24 and 16? If we look on our list, we can see that 8 is in both of our lists, and it is the greatest one. 2 and 4 are in our list, but we want the greatest common factor. So 8 would be the greatest common factor of 24. That should all be review from last year for you. So now, though, we're going to find the greatest common factor of some variable expressions. So if we have 8z to the 4th, m to the 2nd times p, and we're going to subtract 12z to the 3rd, m to the 4th, p squared. So if it asks you to find the greatest common factor of these two, this expression and this expression, the first thing you want to do is to look to see if there are any just numerals. We have an 8 and a 12. So we first find the greatest common factor of 8 and 12, which would be 4. 4 is the largest number that can go evenly into both 8 and 12. Next, we look at this expression, z to the 4th. We have a z over here, and we have another z over here. So we want to look and see how many. We have z to the 4th here and z to the 3rd. So the greatest number of z's being multiplied is 3. That is being multiplied in both. So we would write z to the 3rd. In this expression, z to the 4th means that there are 4 z's being multiplied. In this one, there are 3. So the greatest number that is common to both of them is 3. We can't say 4 because this number right here does not have 4 z's. So the greatest number that they both share is 3. Well, we'll look and see with the m's. This one has m times m, which is m squared. This one has m times m times m times m. The greatest number of m's in both of them is 2. So the next one would be m squared. Last, we have a p and a p squared. The greatest number of p's in both of them is p. So the greatest common factor of this expression would be this right here. Well, we're going to try one more just to make sure that you got it. We're going to try 6x squared y cubed m minus 14x y to the 5th m squared plus 24 x to the 10th y to the 6th m4. Looks like a whole lot of numbers, but it's actually pretty easy. But you have to remember this math tip, which was actually on our quiz. Watch the signs. So important. If that's the only math tip you remember, that one will be the most helpful. So we have to watch these signs. Okay, that's what we have to do when we're factoring it out. So first we're going to find the greatest common factor of all these. Like I said before, we start with just the numbers. We have 6, 14, and 24. When we look at those three, we have to think of what is the greatest number that can go in each of them. Well, the factors of 6 are just 1, 2, 3, and 6. 6 cannot go into 14, although it can go into 24, so it can't be 6. 3 doesn't go into 14. So the greatest common factor that those three numbers share is 2. 2 goes into 6, into 14, and into 24 evenly. Now we have to look at the x's. We have an x squared, an x, and an x to the 10th. the greatest number of x's found in each of these three expressions is just 1. This one only has 1, so we can't use any of the higher numbers. We look at the y's, y to the 3rd, y to the 5th, and y to the 6th. 3y's is the highest number that is found in all three of these, so this would be y to the 3rd. Next, finally, we look at the m's. There's 1m, 2m's being multiplied together, and 4m's being multiplied together. Just as a reminder, that means this. And if we look at all three of those expressions, the greatest number of m's that can be found in each of these is just 1. So the answer to finding the greatest common factor of this expression would be 2x y to the 3rd m. Now something you'll find in the next chapter, in chapter 35, is once we find the greatest common factor, we can then factor this out. So if the problem says factor, I will explain what that means. Factoring this expression is the opposite of factoring this expression is the opposite of the distributive property. So I'm going to move this aside for just a moment, and I want to go back and show you something. So if we had something like this, 2x times b plus 24x minus, let's say, 3xy. To do the distributive property, that just means we have to multiply 2x by each of these, and remembering to watch the signs. So 2x times b would be 2xb, plus 2x times 24x would be 48x squared. And then we would take this minus sign and multiply 2x times 3xy, which would give us 6x squared y. Factoring is the opposite. We just did the distributive property to go from here to here. When we factor out a common factor, it's the opposite. So when looking, if this said factor out the greatest common factor and factor this expression, we would do what we just did on the other page. We would look at the numbers 2, 48, and 6, and we would look for the greatest number, the greatest factor that could be taken out of all three of those, which would be 2. Then we would look at the x's. We have 1x, 2x's, and 2x's. So the greatest number of x's would be x. And we look at the b's. There's 1b. There isn't any b's right here, and there isn't any b's right here. So we cannot take a b out of all three of these things because these ones don't even have one. And the same goes for the y. We can't take a y out of all of these because this is the only one with a y. So the greatest common factor of those would be 2x. Now here's where when it says to factor it out. So if we take 2x out of 2xb, if we divide 2xb by 2x, what do we have left? If we divide 2xb by 2x, those cancel out, and we're just left with b. So b would go right here. Then we take this sign and put it right here. And we do the same thing with this expression. If we have 48x squared, and we take out or divide 2x, we are left with 24x. X squared divided by x just leaves x. So we have 24x. Next we watch this sign, which becomes negative, and we do the same thing for this last one. We take 6x squared, and if we take out 2x or divide 2x, the 6 divided by 2 becomes 3, x squared divided by x becomes x, and the y divided by nothing stays y. So can you see then how we are right back to our original equation. This one and this one are the same. So factoring out the greatest common factor is the opposite of the distributive property. So we're going to look at that with this last one that we just did. We found the greatest common factor, 2x, y to the cubed m. It was the greatest common factor of these three expressions. So if we are going to factor this, we're going to take 2x, y to the cubed m out of each one of these. When I say take it out of, I mean we're going to divide them. So 6 divided by 2 leaves 3. X squared divided by x leaves just x. Y cubed divided by y cubed is just 1. So since they're being multiplied, we can just not worry about the 1 because they're being multiplied. If it was being added, this is super important, we would have to worry more about the 1. But 3x times 1 is simply 3x. So we don't have to write the 1 there. The same thing goes with this m. M divided by m equals 1. And because it's being multiplied, we don't have to rewrite it. So we factored 2xy cubed m out of this first one. Now we take that sign, carry it down. We have 14 divided by 2, which leaves 7. X divided by x is again 1, so we're not going to worry about putting it down there right now. Y to the 5th divided by y to the 3rd is y squared. And m squared divided by m is m. We have one more term to look at. We're going to add. We have 24 divided by 2, which is 12. X to the 10th divided by x leaves x to the 9th. Y to the 6th divided by y third is y to the 3rd. And m to the 4th divided by m is m to the 3rd. So factoring out the greatest common factor of this gives you this answer right here. And as you can see, that's the opposite of the distributive property. If we would do the distributive property and multiply this by this whole thing, we would distribute that term to that term and to that term, and we would end up with the same thing. 2xy to the cubed m times 3x equals 6x squared y cubed times m. Then this multiplied by this equals minus, watching the sign, minus 14x y to the 5th m squared. Now we have to do it one more time. Plus 2 times 12 is 24. X times x to the 9th is x to the 10th. Y to the 3rd times y to the 3rd is y to the x. And m times m to the 3rd is m to the 4th. So can you see we just got these two terms right here. These are the same. So factoring out the greatest common factor is the opposite of the distributive property.